Imagine this. One night you look up at the sky and see countless stars flickering, so far away it feels impossible that humans could ever reach them. And yet, hidden in that vast darkness are tiny messengers from Earth, space probes, satellites that no longer see our planet, no longer see the sun as the blazing giant we witness every day. To them, the sun is just another star, a little brighter than the rest, but no longer majestic or familiar. So, what do these silent machines see when they wander that far? And more importantly, what stories do they carry back to us? About the universe, about our origins, and about our future? That's the question that begins a remarkable journey. We'll follow in the path of the farthest spacecraft humanity has ever launched, and listen to the tale they've been telling. A tale that begins in the brilliance of the sun, sweeps past the giant planets with their raging storms, brushes against frozen worlds, then crosses the invisible frontier where the sun's reach fades and drifts into interstellar space, a realm no human has ever set foot in. But before we fly with them, it's worth asking, why go so far at all? Why not stop at exploring Earth, or the Moon, or even Mars? Why send out machines that may take decades, centuries, or even millennia before they ever reach their destination? The answer lies in humanity's unquenchable curiosity. Since the earliest days, our ancestors stepped out of caves, left familiar lands, and wondered what lay beyond the horizon. When the first wooden boats pushed into open seas, no one knew what awaited on the other side. They only knew they had to go. Today, in the age of science and technology, space probes are our new wooden ships, sailing into the cosmic ocean to expand the map of human knowledge. And these missions aren't just about curiosity. They carry the deepest questions about existence itself. How does the sun really work? And why does it sometimes hurl storms of charged particles strong enough to cripple Earth's communication systems? Could Jupiter, Saturn, or their icy moons harbor life? And what happens when humanity must one day leave Earth behind in search of another home? To find answers, we can't stand still. We have to launch. But sending spacecraft that far is no easy feat. Distance is the greatest obstacle. Even at the fastest speeds we've ever achieved, it takes years to reach the outer planets and decades to break free of the sun's grasp. Communication becomes a monumental challenge too. On Earth, a text message travels almost instantly. But for a probe like Voyager, a simple signal takes more than 20 hours to reach us, and that's when it's only a few dozen billion kilometers away. Imagine when it drifts 2 or 3 times farther, and a single reply could take days. Then there's the problem of survival. Here on Earth, a computer slows down or breaks after a few years. But these probes must endure for decades in a frozen, radiation-filled void, battered by micrometeorites. To achieve that, engineers had to build systems that could protect themselves, adjust course on their own, and keep working without constant human help. And yet, it's these very difficulties that make every success feel miraculous. When Voyager sent back that photo of Earth, a faint pale blue dot suspended in darkness, it wasn't just a picture. It was a reminder that everything we know, everyone who has ever lived and dreamed, exists on that tiny speck of dust caught in a sunbeam. When the Parker Solar Probe plunged into the sun's outer atmosphere, it wasn't just transmitting data. It gave us the feeling that even though we are small, we can still touch the secrets of the star that sustains life on Earth. These spacecraft, though soulless, have become humanity's sentinels on the cosmic frontier. Tireless, relentless, they keep sending signals like distant heartbeats, reassuring us that eyes and ears are still out there, watching on our behalf. And from those distant eyes, a story takes shape. A story not only about planets and stars, but about humanity's place in the universe. Because each time we learn a little more about the solar system, we also learn a little more about ourselves. So when you're ready, let's continue the journey. Let's lift our gaze from Earth and look farther, toward the very edges of the planetary system we call home. Because the first thing these spacecraft help us see more clearly isn't a distant alien world, but the closest star of all, our sun. If in the previous chapter we paused at the question of why humanity sends spacecraft so far from home, then what comes next is the answer in action. Once we were ready, those ships hurled themselves forward, diving into the blazing heart of the solar system, swinging past the gas giants and venturing into worlds no one had ever seen before. It was a journey equal parts daring and brilliance, where every mission became a chapter and every stream of data a line in the shared story of our species. The first name in this saga could only be the Parker Solar Probe, a small but fearless craft built to do what no machine had ever dared, fly straight into the sun's fiery crown. To us, the sun is both light and life, but it is also a great mystery. Why is its outer atmosphere, the corona, hundreds of times hotter than the surface below? Why do solar storms suddenly erupt, blasting out torrents of charged particles at terrifying speeds, powerful enough to cripple satellites and shut down power grids on Earth? For decades, scientists could only observe from a distance and speculate. Parker changed that. Shielded by a heat-resistant armor able to withstand thousands of degrees Celsius, it plunged closer to the sun than any spacecraft before it. At that distance, it became the fastest human-made object in history, racing through space at nearly 700,000 kilometers per hour. The data it sent back painted invisible pictures of our star, not a quiet sphere of fire, but a roiling ocean of energy, where tangled magnetic fields twist and snap, driving the solar winds that rush beyond the planets. Parker didn't just reveal secrets, it became a shield of knowledge, helping humanity foresee and prepare for cosmic threats. But the sun was only the beginning. Once we understood more about the heart of the system, our gaze turned outward to the giant planets standing as its gatekeepers. And among those missions, one name shone brightest: Galileo. Launched in the late 1980s, it took nearly 8 years to arrive, but once it settled into orbit around Jupiter, humanity for the first time had a constant presence circling the giant. Before that, we had only blurry snapshots from quick flybys. Galileo lingered long enough to reveal a system far more complex than anyone had imagined. Io, Jupiter's closest moon, turned out to be the most volcanic place in the solar system, where lava fountains tower higher than Everest, creating scenes we once thought unique to Earth. Yet here, the driving force was not molten rock within, but the crushing tidal pull of Jupiter itself. Then came Europa, the frozen jewel. Beneath its thick, icy crust, Galileo found signs of a vast hidden ocean, hundreds of kilometers deep, a place where, around hydrothermal vents in eternal darkness, life might quietly thrive. Ganymede, the largest moon of all, surprised us with its own magnetic field, hinting at a molten core inside. And Callisto, battered and scarred with ancient craters, stood as a frozen archive of the solar system's earliest history. Galileo showed us that Jupiter wasn't just a giant planet, but the center of a miniature universe, with moons that told stories of fire, ice, magnetism, and perhaps even life. When Galileo's mission ended, humanity's eyes turned to another giant, wrapped in shimmering rings, Saturn. To study it, we had Cassini, a spacecraft that wrote one of the most glorious chapters in planetary exploration. Cassini gave us the most breathtaking images of Saturn's delicate rings, but also revealed that they were not fixed, but ever-changing, shaped by tiny moons, sunlight, and perhaps even destined to fade away. And Saturn was more than its rings. Cassini brought us to Titan, its largest moon, a strange world with a thick atmosphere, methane rivers, and seas of liquid hydrocarbons. When the Huygens lander, carried by Cassini, touched down, humanity set foot on a distant moon for the first time, gazing at frozen rocks as hard as steel and orange skies lit by an alien sun. Then came Enceladus, a small moon with an enormous secret. From its south pole, towering geysers blasted water vapor and ice into space, stretching hundreds of kilometers high. When Cassini flew through them, its instruments found water, ice, and complex organic molecules, evidence of a hidden ocean beneath the icy shell, warmed by geothermal energy and possibly capable of supporting life. Enceladus, once overlooked, became one of the most promising places in the search for extraterrestrial life. Parker, Galileo, Cassini, 3 missions, 3 slices of the solar system. One ship plunged into the sun to uncover its mysteries. Another orbited Jupiter to reveal its moons, and a third danced through Saturn's rings to uncover hidden worlds. Each brought back a piece of the puzzle, and together they revealed a solar system not just beautiful, but alive, dynamic, and brimming with possibilities. And now, after listening to the stories of these gas giants, we must press on. Because farther still, beyond the cold shadows, waits a world once known as the 9th planet. Perhaps no mission in modern cosmology had ever been awaited with as much anticipation as the journey of New Horizons. For decades, Pluto remained a world beyond reach, a faint speck of light in telescopes where everything we knew was vague at best. People knew it was cold, tiny, and distant, but its true shape, its surface, even its color had never been seen directly. Then in 2006, when Pluto was demoted from planet to dwarf planet, curiosity grew even stronger. Was this little world really worthy of being called a planet? And so, New Horizons was launched, carrying the hopes of answering all those questions. 9 years later, in July 2015, the world held its breath. After traveling more than 3 billion miles, New Horizons finally reached Pluto and sent back the very first close-up images. It was like opening an ancient book sealed for millennia, its pages unfolding one by one before our eyes. Pluto was no longer just a point of light, but a breathtaking dwarf planet with a richly detailed and colorful surface. The most astonishing discovery was the image of a massive, bright, heart-shaped ice plain, later named Sputnik Planitia. It felt like Pluto had left a message for us, saying, "I too am part of the cosmic story, and I have a heart." But Sputnik Planitia wasn't just beautiful, it revealed Pluto's surprising vitality. Its nitrogen ice showed signs of flow and fracture, hinting at possible geologic activity beneath the surface. Towering ice mountains, as large as the Rockies on Earth, but made entirely of frozen water, rose against the horizon. Pluto's thin atmosphere glowed faint blue, forming a soft halo as sunlight passed through, like an eternal twilight encircling the planet. The long-held belief that Pluto was a dead, frozen, motionless world suddenly collapsed. Instead, it appeared alive, dynamic, and changing in its own unique way. New Horizons didn't stop with Pluto. It turned its gaze to Pluto's companions. Charon, the largest moon, emerged as a world of its own, scarred with vast canyons and fractures stretching hundreds of miles, evidence of a turbulent geological past. A large dark patch near Charon's North Pole intrigued scientists so much that it was nicknamed Mordor Macula, evoking Tolkien's shadowy realm. Beyond Charon, New Horizons captured images of Pluto's smaller moons, Styx, Nix, Kerberos, and Hydra. Misshapen and peculiar, they look like wandering chunks of rock, reflecting faint light in the cosmic darkness. They seemed like untouched relics, fragments left behind from the earliest days of the solar system. The success of that 2015 flyby didn't just change how we saw Pluto, it reshaped our sense of what might lie at the solar system's edge. The once-forgotten frontier, thought to contain only barren rocks, could in fact be teeming with strange and vibrant worlds. New Horizons pressed onward into the Kuiper belt, a vast realm of ancient icy bodies. In 2019, it encountered Arrokoth, a small but revealing object. With two lobes fused together like a cosmic snowman, Arrokoth, once nicknamed Ultima Thule, showed scientists how primordial worlds were born, not in violent crashes, but in gentle mergers as drifting bodies slowly came together. Arrokoth became a time capsule, a window into the solar system's youth, 4.5 billion years ago. Since then, New Horizons has continued to explore the Kuiper belt, home to famous objects like Eris, Haumea, Makemake, and Sedna. Each name carries its own mystery. Eris, nearly Pluto's twin in size, was the reason Pluto was demoted in the first place. Haumea, strangely elongated and spinning rapidly, is encircled by a faint ring system. Makemake glows deep red in infrared light, while Sedna follows a bizarre orbit so distant and stretched that it raises a haunting question. What force pulled it so far from the giants of the solar system, setting it adrift on such an unusual path? From these questions, a bold idea emerged. Could there be a ninth planet hidden in the darkness of the Kuiper belt? The orbits of several distant objects seem to suggest the presence of a massive unseen body, many times larger than Earth, tugging on them with its gravity. No one has ever observed this Planet 9 directly, but it has become one of the most exciting hunts in modern astronomy. If one day it is found, New Horizons will be remembered as the first step that led us there. Looking back, Pluto was never the final destination, but a doorway. Beyond it lies a frozen graveyard where billions of icy relics have been sleeping for billions of years, waiting for us to uncover them. So far, we've only knocked lightly on that door, glimpsing just a few scattered pieces. Yet what New Horizons revealed is enough to remind us that this cold frontier is not a barren wasteland, but a treasure vault, a library of the solar system's earliest history. And so that historic flight was not just our first encounter with Pluto, but the opening chapter of a new era in humanity's journey outward. A chapter with countless unwritten pages still waiting to be explored. When New Horizons sent back the first close-up images of Pluto and Arrokoth, scientists realized they were only standing at the doorway. Beyond it stretched an entire hidden kingdom, vast and cloaked in darkness. The Kuiper Belt, beginning just past Neptune's orbit and extending billions of kilometers outward, is both a graveyard of frozen worlds and a time capsule holding the solar system's earliest memories. If our planetary system were a novel billions of years long, the Kuiper Belt would be the opening chapters, still intact, untouched by time. Unlike the giant planets that have been reshaped over billions of years, the objects of the Kuiper Belt remain almost unchanged since the solar system's birth. They are frozen mixtures of ice, methane, nitrogen, and organic compounds, locked in a frigid stillness where temperatures hover near minus 230 degrees Celsius. And in that stillness lies their value. They are living relics of the past, the building blocks that once assembled into the planets we see today. The Kuiper Belt is far from empty. Thousands of objects have been identified, and millions more remain unseen. Some are massive, like Eris, Haumea, Makemake, and Sedna, each carrying its own mystery. Eris, rivaling Pluto in size, once ignited fierce debates that ultimately led to Pluto's reclassification as a dwarf planet. Haumea, oddly stretched like a rugby ball, spins so fast it completes a rotation in less than 4 hours. Makemake glows a deep red in infrared light, hinting at complex organic compounds on its surface. Sedna's orbit takes tens of thousands of years to complete, so distant that astronomers wonder if it truly belongs to the Kuiper Belt or if it strays into an even more remote frontier. Neptune itself plays a hidden role in shaping this icy realm. As the giant planets migrated outward in the solar system's youth, Neptune's immense gravity sculpted the Kuiper Belt, scattering some objects, bending others into eccentric orbits. Today, many of these worlds still move in resonance with Neptune, as though they're dancing to the deep blue giant's gravitational rhythm. To scientists, the Kuiper Belt is nothing less than a colossal natural laboratory. By studying its objects, their chemistry, their sizes, their orbits, they can reconstruct the solar system's earliest chapters, discovering how planets came to be and why some grew into giants while others remained fragments of ice and rock. And the deeper we look, the stranger it becomes. The Kuiper Belt seems to hold not just isolated objects, but hidden patterns and connections. Groups of bodies move together, their elongated orbits whispering of something more, a massive unseen influence. This is the seed of the Planet 9 hypothesis. A giant planet, 5 to 10 times Earth's mass, lurking in the farthest shadows, too distant for even our most powerful telescopes to catch easily. If it exists, then the Kuiper Belt is more than a relic of the past. It's a gateway to a new chapter in astronomy. Yet, even without Planet 9, the Kuiper Belt carries a deeper meaning. It reminds us that the solar system does not end with the last familiar planet. There is still a vast frontier, filled with untold stories. As New Horizons passed through, humanity was reminded that knowing the Kuiper Belt is as vital as knowing the continents of Earth. Every glance at the Kuiper Belt is also a glance backward at ourselves. Those tiny frozen shards prove that from chaos, planets can emerge. And in at least one miraculous case, one of them became a home for life. Studying the Kuiper Belt is not just curiosity. It's a way to retrace Earth's own evolution and to wonder whether other Earths are forming right now around distant stars from disks of ice and dust, much like this one. And when we imagine leaving the Kuiper Belt, it feels like stepping out of a silent graveyard into an endless desert. But silence here is not an ending. It's an invitation. Because beyond the Kuiper Belt lies an even greater mystery, a vast shell surrounding the solar system where sunlight itself fades into memory. If one day we go farther still, beyond the Kuiper Belt's edge, what awaits us is the Oort cloud, a colossal shadowy sphere that envelops our entire planetary system. Beyond the Kuiper Belt, where icy relics from the dawn of the solar system still drift in the dark, humanity once thought it had reached the edge of everything. But what we call the boundary is really just the foyer of a much larger chamber. Encircling all the planets is a vast shell that stretches to distances almost impossible to imagine. This is the Oort cloud, a dim and distant realm filled with countless frozen fragments, wrapping the solar system like a shimmering, invisible bubble. No one has ever seen the Oort cloud directly. No telescope, no matter how powerful, can sketch it into an image. Everything we know comes from indirect clues, from sudden visitors that streak across our skies. When a comet millions of kilometers long dives toward the sun, astronomers suspect it was born in that faraway place. Nudged by the gravity of nearby stars or by random shifts in its orbit, the comet is pulled from hibernation, beginning a journey that can last millions of years until it finally brushes past Earth, only to be slowly stripped away by the heat and light of the sun. These wandering travelers remain our most compelling evidence that beyond the veil of darkness lies a hidden archive of primordial worlds. Scientists estimate that the Oort cloud begins around 2,000 astronomical units and may stretch all the way to 100,000. One astronomical unit is the distance from Earth to the Sun, about 150 million kilometers. That means the outer edge of the Oort cloud could be nearly 15 trillion kilometers away, almost a full light year. On the cosmic scale, that's still just a short step compared to the gulfs between stars, but to the human imagination, it feels like an endless ocean. What makes the Oort cloud so special isn't just its size, but its role in history. Think of it as a cosmic filing cabinet, preserving fragments from the solar system's earliest days. While the planets have been reshaped for billions of years by impacts, volcanoes, and tectonics, the icy bodies of the Oort cloud remain nearly unchanged since 4.5 billion years ago. To study them is to open a window directly into the time before Earth, Mars, or Jupiter were fully formed. The problem, of course, is how to study something we can't see. That challenge makes the Oort cloud both tantalizing and remote. For now, astronomers can only trace the paths of comets backward, hoping to reconstruct their origins. But the dream goes further. To launch an interstellar probe, a spacecraft that could cross the edge of the heliosphere, the vast magnetic bubble inflated by the solar wind, and step into true interstellar space, inching closer to the Oort cloud itself. The heliosphere acts like a protective cocoon, shielding the planets from much of the galaxy's dangerous radiation. It extends tens of billions of kilometers, and at its frontier, the solar wind weakens until it collides with the thin gas of the Milky Way. Beyond that boundary, a probe would leave the familiar home of the sun and, for the first time, set sail in interstellar waters. If it could travel farther still, it might drift into the icy shoals where the Oort cloud begins. A mission like this would not only give us our first direct glimpse of primordial ice, but also help define where the solar system truly ends. Of course, such a mission is not one that could be completed quickly. A journey to the Oort cloud might take centuries, even millennia. But even charting a course, preparing the technology, and sending the first probes to the edge of the heliosphere would be a historic step. It would show that humanity isn't content to remain nestled inside the sun's cocoon, but longs to rise and stride into the vastness of the galaxy. In many ways, the Oort cloud is a mirror of that longing. It doesn't shine, it can't be seen with the naked eye, but it is always there, surrounding us, whispering that the solar system does not end with Pluto or the Kuiper belt. Beyond lies a frozen mantle, and beyond that, the galaxy itself. And when we talk about probes at the edge of the heliosphere, there's a remarkable truth to remember. 2 spacecraft have already ventured so far that while they haven't reached the Oort cloud, they have crossed into interstellar space. They are the legendary Voyagers, launched in the late 1970s, still out there today, sending faint signals home from the dark between the stars. In 1977, in a fateful moment, 2 small spacecraft were launched from Earth with a mission that sounded like pure science fiction at the time. To journey past all the giant outer planets and then drift on forever, carrying with them the story of humanity. They were called Voyager 1 and Voyager 2. And today, 45 years later, they are still out there, still whispering back faint signals from a distance so vast that even light takes many hours to reach Earth. If we talk about the greatest legacies of human civilization, these 2 spacecraft surely deserve a place on that list. Voyager was designed to seize a rare opportunity. In the late 1970s, the four gas giants, Jupiter, Saturn, Uranus, and Neptune, lined up in such a way that a single spacecraft, if launched on the right trajectory, could fly past them one by one. This alignment happens only once every 2 centuries, and NASA wasn't about to miss it. Voyager 2 launched first, followed by Voyager 1. Each was no bigger than a car, yet packed with instruments powerful enough to open a whole new era of astronomy. When Voyager 1 and 2 reached Jupiter, they transformed our view of the solar system. Until then, Io, one of Jupiter's moons, was thought to be a frozen, lifeless rock. But the images shocked the world. Io was erupting with volcanoes, hurling plumes of lava hundreds of kilometers into space. For the first time, humanity witnessed active volcanism beyond Earth. Europa, another moon, revealed cracked sheets of ice hinting at a hidden ocean beneath, raising the possibility that it might harbor life. That first encounter with Jupiter alone was enough to change how we see the solar system, far more complex and dynamic than we had imagined. From Jupiter, Voyager pressed on to Saturn. This time, the spacecraft unveiled the breathtaking beauty of Saturn's rings, not just faint streaks through telescopes, but intricate structures visible down to icy particles. Voyager also observed Titan, Saturn's largest moon, cloaked in a thick and mysterious atmosphere. Its surface remained hidden, waiting decades until Cassini and Huygens revealed more. But it was Voyager that first planted the seed of curiosity. Voyager 2, after Saturn, kept going, becoming the only spacecraft ever to visit both Uranus and Neptune. At Uranus, it discovered a pale blue planet tilted on its side, spinning almost horizontally, along with moons unlike any seen before. At Neptune, it captured images of the Great Dark Spot, a massive storm resembling Jupiter's Great Red Spot but swirling in an atmosphere rich with methane. These encounters turned distant specks into real worlds, each with its own personality. When the grand tour was done, neither Voyager slowed down. Both continued straight on, leaving the sun behind. By the early 2010s, a milestone was reached. Voyager 1 officially crossed the boundary of the heliosphere, entering interstellar space. Voyager 2 soon followed. For the first time, human-made objects had slipped beyond the sun's protective bubble and into the vast ocean of the Milky Way. Astonishingly, they still work. Even decades past their design lifetimes, their instruments continue to send back data about particle density, radiation, and magnetic fields. Precious information about the frontier between our solar system and the interstellar medium. This isn't just science, it's a symbol. We are hearing the first whispers from beyond the cosmic cradle that has sheltered us. And as if that weren't enough, Voyager carries a more poetic mission, a message to the cosmos. Attached to each craft is the Golden Record, a phonograph disc etched with sounds, images, and greetings from Earth. It holds the cry of a newborn baby, the crash of ocean waves, the rush of wind, the music of Beethoven and Chuck Berry, 115 pictures of Earth's diversity, and greetings in 55 languages. Carl Sagan, who spearheaded the idea, described the record as a message in a bottle cast into the cosmic ocean, with the hope that someday, somewhere, another intelligence might find it and know that a small species on a pale blue planet once looked up and said hello. The Golden Record will almost certainly never be found. But that isn't the point. Its meaning lies in the act of sending it, in declaring that humanity's story is worth telling, even into the cold silence of the galaxy. When Voyager 1 looked back at Earth from more than 6 billion kilometers away, it captured the famous pale blue dot. In that image, Earth is nothing but a faint blue speck, smaller than a grain of dust, suspended in a sunbeam. Carl Sagan's words about it became immortal, reminding us that every war, every ambition, every love, every joy and sorrow, all of human history, has played out on that tiny dot. There is nowhere else for us to go, and so we must take care of it. Voyager's legacy isn't just in scientific discoveries, stunning images, or unexpected findings. It's also in what it represents. That humanity, small and fragile as we are, can still build machines that escape our home star and wander into the interstellar sea. Voyager turned a dream into reality, proving we can break through limits that once seemed impossible. And like a beautiful metaphor, Voyager keeps flying, keeps going, even though one day its power will fade and its voice will fall silent. Even then, the spacecraft will drift among the stars, carrying the golden record as an eternal calling card. For millions, even billions of years, they will be silent witnesses to a civilization that once looked up at the sky and asked where it came from. But the story doesn't end there, because when it comes to the search for life, Voyager isn't the only legacy. A new generation of spacecraft and telescopes is carrying that mission forward, tracing faint chemical signatures that may one day reveal we are not alone. For thousands of years, people have looked up at the night sky and wondered, are we alone in the universe? It's a question at once simple and enormous, both a deep philosophical riddle and one of science's toughest challenges. The Voyager probes gave us our first hints of the astonishing variety of worlds in our solar system. But to go further, to search for life, or at least for its earliest traces, we need more sophisticated tools and bolder methods. That's when a new generation of telescopes and space probes takes the stage, leading us into the quest for life and molecular signatures. At the forefront of this search is the James Webb Space Telescope, or JWST, the crown jewel of modern astronomy. With its massive gold-coated mirror, JWST can capture the faint light of stars and planets tens or even hundreds of light years away. But what truly sets it apart isn't just sensitivity, it's spectroscopy, the ability to break starlight into its colors and read the fingerprints of molecules. When an exoplanet passes in front of its star, a fraction of the starlight filters through its atmosphere, carrying with it the telltale marks of molecules. Water vapor leaves one kind of signature, methane and carbon dioxide others, even ozone. And if one day JWST, or the telescopes that follow, detects a special combination, like oxygen and methane coexisting, that could be a powerful hint that life is present. JWST has already begun its first observations, and the results are promising. On several exoplanets, it has spotted traces of water and methane, suggesting that many worlds are not just barren rocks, but may host complex atmospheres. Of course, water doesn't guarantee life, but it's the most crucial ingredient. With its deep gaze into the cosmos, JWST acts like a giant microscope, letting us peer into the homes of distant neighbors, straining to hear if anyone is whispering back across the void. While JWST watches from afar, another line of missions takes the opposite approach, not just looking, but touching and bringing samples home. One of the most striking examples is OSIRIS-REx. It journeyed to Bennu, a small but ancient asteroid thought to preserve the original material from the dawn of the solar system. After years of travel, the spacecraft descended onto Bennu's rubble-strewn surface, scooped up samples, and carried them back to Earth. When scientists opened the container, they found amino acids, the basic building blocks of proteins, and therefore of life itself. That discovery suggests Bennu is not only a living record of history, but also that asteroids like it may have delivered key chemical ingredients to the young Earth, planting the seeds of life. Around the same time, Japan launched a similar mission, Hayabusa 2, which visited the asteroid Ryugu. Its return samples also contained organic compounds, strengthening the idea that life may have started with cosmic gifts carried in by asteroids and comets. Even the European Rosetta mission, which rendezvoused with Comet 67P Churyumov-Gerasimenko, detected complex organic molecules locked in ice. Together, these findings breathe new life into the idea of panspermia, the notion that life, or at least its raw materials, may have been sown from space. Here on Earth, every living thing is built from the same organic ingredients. Plants, animals, and humans alike are woven from carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. Finding these molecules on asteroids and comets suggests that life may not be a rare, Earth-only phenomenon, but rather the natural outcome when common elements meet under the right conditions. If that's true, the universe could be teeming with life, from simple microbes to entire ecosystems waiting to be discovered. Of course, there's a vast distance between potential and actual. A handful of amino acids is not the same as cells, DNA, or intelligence. But in science, every small step builds the foundation for the next. Bit by bit, we are sketching the outline of a universe where life could thrive. Confirming extraterrestrial life, even just microbes, would be the most profound discovery in human history. What's remarkable is that in searching for life elsewhere, we also learn more about ourselves. By studying samples from Bennu or Ryugu, we hold up a mirror to Earth's earliest past, asking, how did life on our planet begin? Was it a rare, one-time accident, or the inevitable outcome of chemistry? If life arises easily, then the cosmos may be filled with neighbors. We just haven't come close enough to hear them yet. This journey is still in its early stages, but humanity has already taken its first bold steps. From spacecraft daring to touch asteroids, to telescopes listening for faint signals in distant atmospheres, each effort is helping write the shared story. And with every step, it becomes clearer that we are not only searching for an answer to the question, is anyone out there? But also for the origins of life on Earth itself. And so, realizing that the present is just the prologue, we can see the future will be even more daring. New missions are already being planned, new spacecraft designed, and dreams continue to burn brightly in the human imagination. For decades now, humanity's brave machines have carried us to the very edge of wonder, from the blazing winds of the sun to icy geysers erupting on Enceladus, from Pluto's frozen heart to the vast interstellar void where the Voyagers still wander. Yet all of these discoveries are only the opening chapter. If the present is the prologue, then the future will be the bolder story, one where we don't just watch from afar, but step forward into the most promising worlds, seeking answers to the oldest question of all: is life out there, beyond Earth? One of the most exciting upcoming missions is Europa Kuiper, a spacecraft designed to study Jupiter's moon Europa in unprecedented detail. Ever since Galileo first revealed signs of a hidden ocean beneath its icy crust, Europa has stood out as one of the most likely places to host alien life. Many scientists believe this ocean, buried under an ice shell tens of kilometers thick, could hold twice as much water as all of Earth's oceans combined. Even more intriguing, it might be warmed by tidal forces from Jupiter's immense gravity, creating conditions similar to Earth's hydrothermal vents, ecosystems where life thrives without sunlight. Europa Kuiper, scheduled to launch in 2024 and arrive in the next decade, will loop around Europa dozens of times. It will capture high-resolution images, peer beneath the ice with radar, analyze the surface, and most importantly, investigate the mysterious plumes of water vapor Hubble once glimpsed erupting from Europa. If those plumes are real, the spacecraft could fly right through them, sampling their contents for salts, organic molecules, even potential biosignatures. If anywhere in the solar system resembles a living laboratory, it's Europa, and Kuiper will be the first true eye peering inside. Meanwhile, Europe is charting its own course. The European Space Agency, ESA, is developing a mission called JWST, short for Jupiter Icy Moons Explorer. Unlike Kuiper's sharp focus on Europa, JWST will take a broader view, studying 3 of Jupiter's icy moons: Ganymede, Europa, and Callisto. Among them, Ganymede stands out. It's the largest moon in the solar system, bigger even than Mercury, and the only one known to have its own magnetic field. Scientists suspect an ocean lurks beneath its vast icy shell, and exploring its magnetism, structure, and chemistry could deepen our understanding not only of habitability, but also of how icy worlds form and evolve. Callisto, ancient and crater-scarred, may seem less dynamic than Europa or Ganymede, but its very stillness makes it a time capsule of the early solar system. By comparing these 3 worlds side by side, JWST could reveal why some moons hold the ingredients for life, while others remain forever frozen. Together, Kuiper and JWST, one from America, one from Europe, show that the search for life is not the dream of a single nation, but a quest that belongs to all of humanity. If Europa and Ganymede are enigmas waiting to be unraveled, Titan, Saturn's largest moon, is a wonder that has already whispered part of its story, yet still holds countless mysteries. Titan has a thick atmosphere rich in nitrogen and methane, with clouds, rain, rivers, and lakes, but all made of liquid methane instead of water. It's the only place beyond Earth where liquids flow across the surface, creating landscapes that look strangely familiar, yet are built from alien chemistry. That's why NASA has planned a mission unlike any before. Dragonfly. Dragonfly, set to launch in 2028, won't be an orbiter or a stationary lander, but a flying drone with 4 rotors, able to hop across Titan's varied terrains. Instead of being confined to one site, it will soar from place to place, exploring methane dunes, hydrocarbon lakes, and icy plains. Equipped with advanced instruments, Dragonfly will search for prebiotic chemistry, complex organic molecules that may bridge the gap between lifeless chemistry and living biology. Titan could even offer a glimpse of what Earth was like before life began, billions of years ago. Studying it may let us see the primordial Earth we can never revisit. Picture it, a small drone buzzing through Titan's hazy orange skies, touching down on a frozen dune, then lifting off again to cross a vast methane sea. The image is not just scientific, it's almost poetic, a sign that humanity is beginning to learn how to live, even briefly, in other worlds. Europa Kuiper, JWST, Dragonfly, all share one unifying purpose. They're not simply collecting dry data, they're confronting the question of life head-on. They target worlds where conditions might allow life to emerge, or where chemistry echoes the dawn of biology on Earth. Whether they succeed or fail, they will bring us closer to an answer. And beyond their science lies their symbolism. These spacecraft are monuments to our restless curiosity, to the patience of a fragile species that dares to dream of distant horizons. Because if we truly hope to journey beyond our star someday, we must begin with smaller steps, learning to explore hidden oceans beneath ice, methane lakes under alien skies, and strange worlds that might one day teach us how life takes hold in the cosmos. To embark on journeys that stretch beyond imagination, spacecraft need more than human willpower. They need wings strong enough, forged from technology, to carry them across the void. If Voyager, Galileo, and Cassini stood as testaments to 20th century brilliance, today we are stepping into a new era, one where technology isn't just a tool, but the deciding factor in whether we can reach worlds farther than ever before. One of the most fundamental challenges in exploring the cosmos is communication. Imagine whispering into a microphone while your listener stands billions of kilometers away. The signal from Voyager, traveling back to Earth from interstellar space, is tens of thousands of times weaker than the signal from the phone in your pocket. To catch those faint echoes, humanity built a giant network of antennas, known as the Deep Space Network, stretching across the United States, Spain, and Australia, so that at least one ear is always listening to the sky. Yet even with this system, transmitting data can take hours, sometimes even days, depending on the distance. To overcome this, scientists are developing laser communication, using beams of light instead of radio waves to carry information. A laser can transmit tens of times more data than a radio signal, and when aimed precisely, it dramatically increases speed. That means instead of receiving a handful of blurry images over months, we could one day stream detailed video footage of distant worlds in a fraction of the time. It's like switching from snail mail to fiber optic internet, unlocking an era of high-speed communication across space. And it's not just communication that's evolving, but how we observe the universe. For most of history, we could only see invisible light. But the cosmos speaks many languages. It whispers in infrared, roars in X-rays, flashes in ultraviolet, and even trembles in gravitational waves. Ripples in the very fabric of space-time. Modern science has opened the door to multi-messenger astronomy, meaning we're no longer listening with just one ear, but with the whole cosmic orchestra. The James Webb Space Telescope explores in infrared, Chandra listens in X-rays, and LIGO and Virgo detect gravitational waves from colliding black holes. Together, they paint a richer, multidimensional portrait of the universe, where every wavelength, every vibration, is a piece of the puzzle. Alongside these massive telescopes and complex probes, space technology is also getting smaller. CubeSats, tiny satellites the size of a shoebox, are being launched in growing numbers. They can accompany larger missions, run independent experiments, or capture unique vantage points. With dramatically lower costs, CubeSats have turned space into a more accessible playground, one where not only giant agencies, but also universities and small companies can join the adventure. The push doesn't stop there. Researchers are developing quantum sensors, extremely sensitive instruments capable of detecting tiny changes in magnetic fields, gravity, or time itself. These could allow spacecraft of the future to navigate with pinpoint precision, even in the darkest reaches of space where GPS and starlight fail. At the same time, self-healing materials are being tested, enabling ships to patch microcracks from tiny meteoroid strikes, extending their lifespans for decades-long journeys. Yet perhaps the greatest revolution isn't technological alone, but cultural. For decades, space was the exclusive domain of government agencies. Today, the private sector is charging in at full speed. SpaceX, with its reusable rockets and the massive Starship project, promises to cut launch costs by orders of magnitude. Blue Origin, Rocket Lab, and many others are experimenting with their own approaches. Their participation is accelerating innovation, opening the door to an era where space exploration is not limited by government budgets, but propelled by global collaboration. Picture a future where probes launched by NASA, ESA, or JAXA fly alongside private spacecraft, more often, faster, and cheaper. Instead of waiting decades for a single mission, we could send out multiple expeditions in parallel, each exploring a different corner of the universe. This is the path to transforming space exploration from a rare dream into a steady, enduring effort. New technology doesn't just take us farther, it helps us think differently. It makes once impossible visions conceivable. Giant solar sails pushed by the pressure of photons, compact nuclear reactors powering spacecraft for decades. Even artificial intelligence co-pilots making decisions far beyond human reach. One by one, these ideas are stepping out of science fiction and into reality. Looking back, the thread is clear. From the Deep Space Network to laser communication, from tiny CubeSats to towering Starship, from quantum sensors to self-healing materials, every breakthrough shares the same goal: to carry humanity farther across the cosmic map. Technology is the bridge, and every brick we lay today decides how far we can go tomorrow. In the end, it all leads back to one truth. The images captured by our most distant spacecraft have forever changed how we see the universe. Thanks to technology and innovation, their stories are becoming sharper, their voices clearer, and our own dreams of the stars are soaring higher than ever. As we come to the end of this journey and look back at the paths taken by satellites and probes, it becomes clear that each mission was never just a flight, but a step forward in humanity's collective understanding. Before Voyager, the solar system was little more than points of light in the sky, fragments of theory. But thanks to those patient ships that crossed billions of kilometers, we've seen real worlds. Worlds with winds and storms, with volcanoes and hidden oceans, with atmospheres, and perhaps even the seeds of life. Those images shattered the illusion of a silent universe and revealed that even in our own cosmic backyard, change and motion never cease. The solar system is no longer a flat black canvas dotted with specks of light. It's a complex dance where every planet, every moon, every frozen ring plays its own rhythm. Jupiter is not just a giant ball of gas, but a gatekeeper with moons that hide vast oceans beneath their icy shells. Saturn is more than its stunning rings. It holds Enceladus and Titan, worlds that may be writing the chemical story of life itself. Pluto is not a cold, dead dwarf planet, but an active, icy realm with a heart of nitrogen, blue skies, and mountains of frozen rock. Beyond it, the Kuiper belt and the Oort cloud remind us that the edges of the solar system don't end where our eyes stop, but stretch into uncharted lands still waiting to be discovered. We've also learned that even from unimaginable distances, probes can still be our loyal eyes and ears. Fragile signals that take hours, even days, to reach Earth carry treasure troves of knowledge. They've taught us that patience, persistence, and faith are the most important values for going far. No mission is flawless. Many probes now rest in silence in the dark. But what they sent back before vanishing forever was enough to change the perspective of an entire civilization. More than that, space exploration has changed how we see ourselves. When Voyager sent home the pale blue dot, that tiny blue speck adrift in the vastness, humanity came to understand the fragility of our home. Every moment of history, every civilization, every war and peace, every act of love and sorrow, all of it rests on a dust mote suspended in a sunbeam. There is nowhere else for us, and that makes the duty to protect Earth more sacred than ever. At the same time, these distant missions stir a deep sense of pride. We, a small and fragile species, dared to dream big enough to send a message to the cosmos. The golden record aboard Voyager isn't just a greeting, it's a declaration. We existed, we loved, we created, we sang, and we want you to know that. Perhaps no one will ever find it, but the act of sending it is enough to make it one of humanity's most beautiful symbols. Our journey beyond the stars is only just beginning. Voyager has crossed the heliosphere, but it's traveled only a few thousandths of the way to the nearest star. Other ships, New Horizons, Europa Clipper, Dragonfly, are following, but they too are only taking tentative steps beyond the threshold. Someday, perhaps, true interstellar craft will sail, driven by solar sails or nuclear engines, carrying with them the hope of reaching other suns. That day is still far off, but not beyond reach, because the dream is already planted within us. Looking back on these missions, one question inevitably arises. If one day an alien civilization stumbles upon Voyager and plays the golden record, what will they think of us? They'll hear laughter and tears, music and storms, the sounds of wind and rain, the images of fields and cities and people. They'll know that in this vast universe, there once lived a small species on a distant blue planet, brave enough to look up at the sky and send a greeting. Maybe they'll smile at our innocence or feel moved by our courage. Whatever they think, the golden record will forever stand as proof of one truth. Humanity never stops dreaming of the stars. The universe remains vast, and we've only just stepped outside the doorway. But that's what makes the story so compelling. The solar system isn't still, it's alive, full of motion and possibility. And in this endless journey, every ship, every mission, every faint signal from the dark is a reminder that we can go farther, understand more, and become greater than ourselves.